provocative topic. I don't know if you all are worried about that, if that's something that you think about, but I have an opinion. So we'll get started. The answer is no. That's my opinion, is no. So it will evolve the software engineering role, but it won't eliminate it. And I'll get into details. But before that, why don't I start a bit about who I am, the company I'm from. So I'm Travis Emslander. I'm CTO of Field Nation. And I've been into technology since a very, very young age. I got into programming, and I then pursued my interest with a degree in computer science, and eventually went on to be a software engineer. So right after school, I met a guy named Mainul Khan, who's from Bangladesh. He's a Bangladesh native. And he went to school at the same school as I did, but I never met him during school, even though he also was a computer science major. But we met at an internship. We both got an internship at the same company. And while at that company, we connected, got to be friends, and then a business opportunity came. And Mainul really had the idea for something that we later called Field Nation, but the idea is that there's work happening out in the world that's called field service work. So whenever there's a need at a location, so maybe a store that you go to, they might need a wireless access point installed. Someone has to go do that work. If the store doesn't do it themselves, someone has to get sent out to do that work. And at large stores, chain stores that have many locations, they have that work that they have to do over and over at many, many locations. So an example would be, what if we needed new cash registers at our stores? What if we need to upgrade the wireless? What if we want to start to install self-checkout machines that people can buy stuff without a cashier? Those projects need technical workers to be at many, many locations across the country. And we learned of a need. Oh, thank you. Let me just practice this real quick. Okay. We learned of a need to find many, many workers across the United States, and therefore, get used to the controls. We started Field Nation. So it's an IT field service marketplace. And the general idea is those workers are all over, and we focus on the US market, they're all over the US, and they do this work for many different companies. They do it on contract, so they're going around working for many companies. Why don't we build a website that they can sign up, create a profile, and these companies that have to do it at scale can come to us and say, I have a project, there's 1,000 different jobs at all these stores across the United States, and I need a worker at every single job. So that's where we come in. So here you see a view of aspect of our product. And basically, kind of the key elements are we're helping those companies find the technicians across the US. We help them to actually get the work done once they engage one of those technicians. And then we handle the payment. We take the money from the customer across all the work for their large project, and then we pay all those individuals, because that's really hard to process, thousands of different people that you have to pay. So that's a quick summary of what Field Nation is. And using Field Nation, I want to talk a bit about software engineering, and it's very complex, right? So you're all going to school, you're learning computer science, you're learning theories, algorithms, data structures, all that fun stuff. Once you take that, you build software, you build applications, and it always starts simple. So using Field Nation as the example, it's pretty simple. Someone creates a job. They find a technician, that technician goes, does the work, hits a button, says I'm done, and then we pay him, right? It's not that hard. Why do we need 70 software engineers? It's not that hard. Well, things complexity comes with features. You get customers, they have different needs, they have problems that you learn about that your product isn't servicing. And so, for example, the first that we learned is, well, how do I know that this tech's any good? How do I know this person's going to do good work for me? Okay, well, we need to create ratings, right? You kind of expect that, a marketplace of people, that you have ratings, but that's a feature that we had to create. Next, how do I know that they showed up on time? How do I know that my end customer that needed that thing done at their store is happy because that technician showed up on time? All right, well, we need a process to not only just log the amount of time, but tell us exactly when you started so we can tell the customer real time that they started. And with that comes, well, how do I know they didn't click that button, 50 kilometers away? Okay, GPS location tracking with that check-in feature. Background check. I don't know if that is a thing that you guys do here in Bangladesh, but in the US we have a concept. I'm getting ahead now. Okay, thank you. Of background checks, kind of check people's criminal history, things like that, to give an extra trust signal. So some of our customers are doing work for clients like banks. And they really need to know that the technicians that they send to work on things like ATM, cash machines, that they can trust that individual. So we had to create a mechanism that if technicians were willing to do it, they could go through a background check process and then get the successful background check on their profile. And then financing. So to make this all work initially, what we did is we said, okay, you want to go hire these technicians. You want 500 jobs. And you're going to pay, $100 per job. Well, then put all that money up front with us. We called it pre-funding. And then before the work is even shown to technicians on our marketplace, once the work's completed, we'll use the funds that you already gave us and we'll pay. Well, some of the larger customers that we started talking to said, nah, I'm not going to do that. I'll pay you after. And we wanted their business. They're very large customers with a lot of money potentially. So we introduced a concept of financing, where we will actually pay the technicians out of our bank account, and we'll collect the money later, which is fairly standard practice in this space, but we're able to initially avoid it, which was very helpful when we were a startup and didn't have any money. But eventually we had to do it. And then we had a concept called bundles. I won't even get into the details of that one, but you can see here, as we go on, there's more and more needs. And so even when you start with something that's simple, and the code's fairly simple, it grows over time. You just keep adding features, you keep solving problems, which is great. It builds a product, but the code inherently gets complicated. It has to, it's doing more things. There's also the problem of scale. So you're adding features, that was the previous thing I just talked about, but you also have to handle, you're getting more customers, and the system that you built before may not handle it. Your database might need to be upgraded. You might realize that things are taking too long, we can't do it right when someone clicks a button. You have to introduce a queuing system. You have to put that work into a queue and do it later and tell them the response later. And eventually you'll even get to the point where you realize we really have to restructure this. It wasn't designed correctly. It was probably the right thing at the right time, but now with many more customers, we have to just restructure the way the system works. Additionally, there's things that come up like software often uses libraries. You don't do everything yourself. You look for libraries that can help you. Those libraries have to get updated. If you don't stay up to date on them, you'll eventually get stuck. You'll have problems that you want to do something. The new library can do that, but the pathway to upgrading is very difficult and long. There's also a lot of security issues that can come up as people realize there's security vulnerabilities in the libraries. So you have to stay on top of this. All of this is to paint the picture that things get really, really complicated, right? It's not just writing a few lines of code. There's a lot that goes into software engineering outside of just writing that code. So along comes AI, our savior. It'll solve all these problems and put us all out of work, right? So first let's start with, when people talk about AI, what do they mean? And one problem with the term AI is it means a lot of different things. I listed a few things up here. These are not mutually exclusive. Machine learning is kind of all-encompassing. Most of what you do in AI is considered machine learning. You can do natural language processing, computer vision, deep learning with neural networks. There's lots that go into AI. So when someone says, AI, it's like, well, what exactly are you talking about? And recently, what exactly people are talking about tends to be large language models. ChatGPT, I'm sure you all are aware of it, have used it, played around with it, it's tons of fun. So that is a large language model. And this has birthed what's called generative AI. So it's that these AI tools can actually create new text, new seemingly new thoughts. So it's super exciting. But how does it work? How does the large language model work? First, let me give a caveat. I am not an AI expert, so if you hope that I was an AI expert, I'm going to let you down. But as a technology enthusiast, I like to learn this stuff. So I'll tell you what I've learned and I found really interesting. So if you're interested in this space, one thing I would suggest is this article. You can also find a book. It's the same thing though. What is ChatGPT doing, and why does it work? By Stephen Wolfram. This Stephen Wolfram, he's a genius. He has he's created a lot of software, very sophisticated software. There is something called Wolfram Alpha, which is a cool website. Just you can look up random facts. It's super cool. But he did a really good job in this article of breaking down how do these LLMs work, and he step by step kind of built one. He shows you let's build ChatGPT basically. It does get really confusing, but you can kind of skip the really deep mathematical stuff if you're not interested in it. But the takeaway I have is it is text completion, right? It's just text completion. I shouldn't say just. It's more than that, but the basic idea is text completion. So you see here, the best thing about AI is its ability to what? So if you gave a sentence to one of these large language models, what it would do is it would look at the probability that the next word is learn, predict, make, understand. Learn is the most likely next word in that sentence. And the way that they do that, and this is why it's called large language model, is they train it on huge corpuses of text. And it's kind of neat how they do it. They'll take a sentence and they'll remove a word, and then they'll say, hey, guess what this is? And they know what the word is, they just removed it. And then when the AI makes a guess, they could say, you're right, you're wrong. And then train it over and over to get it to start to understand which word is most likely in that context, in that sentence. So the best thing about AI is its ability to learn would be the next result. So if you keep going down that, ability to learn from, ability to learn from experience, so on, so on, so on. You can see how you just keep running, you keep getting the next word, and it starts to be like someone's talking, right? It starts to be this illusion that someone's talking. So here's kind of a paragraph laid out, and you can read through it. And I won't do that, but you can read through it. One thing you'll notice is it's a bit dry. It's not super interesting, and it gets super weird at the end there. It just starts repeating itself. So because of the way it works, it's saying, well, the next likely word is this, and that gets it into a loop. So that's weird, and I bet when you play with ChatGPT, you never see that. That's something you never see. So what the hell's going on? Well, it turns out that's what you get if you always choose the top result, the most likely next word. That's what happens. So what they did is they figured out, let's not always choose the top result. Let's make it a bit more random. So there's a thing called temperature. How random do you want it to be? And it turns out 0.8 on a scale of 0 being no randomness, what you just saw, to 1 being completely random, 0.8 ends up being a really nice sweet spot. So if you look at this again, and we do this with a temperature of 0.8, you can see kind of the same thing. It doesn't look dramatically different here. Same general concept, it's just guessing a word. But now when you rerun it, you get different results, because every run through, it's random. It's having some randomness. So once it starts choosing words, it's choosing each run, they're going to be a slightly different combination. And then when you generate kind of a paragraph, you notice, just read through that, this sounds a lot better. It sounds like something a human probably wrote. And there's no crazy loop. It doesn't get itself into that crazy loop. So this was super, like, there's a lot more going on in ChatGPT and other things like that, those chatbots. But this is the core idea. If you understand this, you understand how is this stuff working behind the scenes. This is really the core idea. And so there's no AI being. There's no real intelligence there. It's just autocomplete. You're almost getting a similar thing when you just go on your phone's keyboard and you just keep choosing the next option that it gives you for your next word. But it's super cool to play around with. It does some really impressive things, and I'll have some examples later on. But there's also some clear problems. So one that is starting to come up, and some people are pretty upset, is it's trained on lots and lots of text, right? Like I was talking about. Well, a lot of that text, people aren't happy that it's getting trained on, right? Newspaper articles, books that people wrote, and there's an argument going on of, well, if you pay for a book and you learn, you can go off and create other creations. Why can't AI? So that's being discussed, and that'll get at least in the U.S. that will start to be talked about in courts. The other thing is context size limits. So you saw before, the way that this works is you give it some starting text, and then you allow it to keep going off that starting text. And when you have a conversation with something like ChatGPT and you have multiple rounds, your prompt behind the scenes is everything that happened before, as much as it can. So if you feel like, oh, it's really like I'm talking with someone, well, it's because all your conversation up to that point is the starting point. And so that's the context. But there's a limit in how much context can fit. And so there's these context size limits, and if you want to give it really complex problems, like summarize this whole novel, it's probably not going to fit in that context window. It can only fit a certain aspects of the text. And that they keep working on that, so that keeps increasing. But right now, that is a limit, especially when we start thinking about applying it to software engineering and building more sophisticated programs. The code base has become very large, and for it to work on it, it would really have to have the full context to be able to solve, or to be able to work on the whole project. Probably the biggest issue is hallucinations. So that's a term that people have come up with for, it just made something up. And this is where it's helpful understanding how it works, right? Understand what we went through up to this point. Is it doesn't know facts, it doesn't know anything, it's just predicting the next likely word. So it's amazing that it works as well as it does. It's mind-blowing. And the really weird thing is no one really understands why it works that well. they understand the process to get there, but they don't really understand why it seems to know a lot of knowledge, right? You can ask it facts about things, and in most cases, it gives you facts, and they're right. Now, when they're wrong, you have no clue. It tells you confidently, just like it told you when it's right, it tells you, but it's wrong. It'll tell you this person died 10 years ago, and they're standing right next to you. It will just make stuff up. So that's probably the biggest problem with LLMs that, as far as I know, no one has come up with a solution to. All right, so let's give a quick demonstration. So here's my prompt. I'm asking it basically to write a very simple program. The program is put a button in a web page. When someone clicks it, throw confetti all over. Like, virtual confetti. So the first system I used is Google's Gemini. No one really talks much about that one, but it does exist. So Gemini seemed to create it, but I clicked it, nothing happened. And so I brought up the developer tools in Chrome, and I found, oh, there's a JavaScript error. Why is there a JavaScript error? Because it's trying to include some remote JavaScript that doesn't exist anymore. So that did not work. And I tried to ask Gemini, hey, it looks like you're including a JavaScript that doesn't exist anymore. And it tried to help me, and the help didn't work. So we got kind of stuck pretty quickly. So on to ChatGPT. Boom! It nailed it. It got it right. So super impressive. Let's try something a bit more complex. How about a to-do list app? It's everyone's first app, right? If you're making like an Android app or something, you probably make a to-do list. So let's ask it to create a HTML JavaScript-based to-do list app. And now, one thing I'll point out here is in my prompt, I said, hey, please save it. So something to think about there, like I knew to say that because I am a software engineer, right? Would other people that are trying to create programs know to say that? They probably get there eventually when they see the results don't do it. But you can see already, very early on, I'm starting to coach it on how to write the program. So how'd that do? I don't think I even bothered with Gemini on this one. I just did ChatGPT. So it did it. It created a to-do list app. So I could enter a to-do item, click the add to do, and it would show in the list. And sure enough, if I left the page, came back, it was still there. It was saved in my browser. So it got adding, it got storing, so I could come back later and still have the list. It got editing. The UX is not great. You have to know to click it, and a prompt comes up on what to change. But pretty cool, got it. Removing, it didn't, well, it kind of did. You had to right-click the item, and then it would remove. That's kind of a weird design, but I guess functionally it did get it. Reordering, it completely skipped. I asked for reordering, it did do reordering. But interestingly, it knew it didn't do reordering. So in its response, it said, this app doesn't support reordering. To add this functionality, you would need a more complex script or a library like jQuery UI to implement drag and drop. So kind of cool, but I don't know if any of you do web development, modern web development. No, jQuery UI, you don't use that anymore. That's old news. You don't want to be using that library. So that to me starts to raise a concern. What's the quality of this code? What's the quality of the code that this AI is generating? So here's some challenges that I see. Obviously the hallucinations, it did come up in this demonstration in my little samples. Well, it kind of came up, I guess. It had a library that didn't exist anymore on the internet that I tried to use. But in general, it didn't really come up. But that is something that I have hit up against in other attempts to use these LLM systems to generate code, solve code problems. Is, for example, I'll give a quick example. We were trying to debug an algorithm that calculates distance using something called, I think, Helverstein or something method, where it's basically if you have two geo-coordinates, you can calculate the distance, which is more complex than you think because it's on a spherical object. And so there's a whole mathematical function for doing that. And so we had that somewhere in our code, but it was giving wrong results. And it's because it's a very complex math function, it's hard to debug. So I figured, let's see if AI can do it. It told me it could do it. It told me an answer. It was completely wrong. It used the wrong radius of the Earth. It used a completely wrong number. And so that's the stuff that if you don't know to look for it, you could start using the results and you could think that it's right. You could say, this is from a computer program. Computers are never wrong. And it's wrong. The other one is context size. So if we were to continue that to-do list app and we kept adding features, and every single time you have to bring to it, here's everything you've done up to this point. At some point you're going to hit that context window size. It's not going to know everything that it did before. It's not going to remember all the stuff, and it's going to start writing a new app. It's going to start giving you code that doesn't work with the code that you have up to that point. The other one's validation, right? We saw that in Gemini. It gave me code that didn't work, and it didn't know that it gave me code that didn't work. These have no system to validate what they're giving you. There's nothing in place. And then maintainability, security maintenance. The code it's writing is probably not great code. Like when you all go get a position at a company and you start doing software engineering, you'll find that there's practices in place for this. There's something called code review, where you have your changes. You say, here's the changes I think that will do this feature, fix this issue, whatever it is. And you have one of your team members look at it, and they go through line by line, and they go, nope, I wouldn't do it this way. Like this is gonna be hard to maintain. This is gonna create problems. Well, this doesn't do that. This doesn't do it. It doesn't care about it, right? It told me to use jQuery UI when I know that's you want to start moving away from jQuery UI. You don't want to be adding new code using jQuery UI. So, looking to the future, I just wanted to show this. It's called the Gartner Hype Cycle. So Gartner is a technology research and consulting firm, very popular, and they do a lot of research, and they're helpful if you want to know like what's the latest technology to solve this problem. They're going out, they're understanding what software solutions are in place, all kinds of things, and they come back and they can recommend what's good. They created this thing called the hype cycle, or this concept, and it's just based on their observing when new technology comes out. People kind of freak out. They get really excited. They go, "Oh my God, this is earth-shattering," and it kind of is. But the expectations of what it's going to do far exceed what it can do. And so, what I believe, well, actually, let me run through this. So you get up to that peak of inflated expectations. You go, and that's kind of where we are or were. Where this new thing, ChatGPT, came out, it's going to take everyone's job, AI is going to take over. We're on that peak. It was getting crazy. And then what happens is reality sets in. And people start realizing, oh, it can't do this, it can't do this, it has a problem doing this. And you get into this trough of disillusionment. But when you're in that trough, there was a reason people got excited. Like, it does some cool stuff. And so what starts to happen is people go, okay, yeah. It did solve all the world's problems, but it does solve a bunch of problems. And they start applying it to those problems that it works really well with, and you get this slope of enlightenment, and then that plateau of productivity, where now it's a technology that's adopted, people use it all the time, we know how to use it, and you see that play out over and over. Like, I'm gonna date myself, but like when iPhones came out, there was that, and it ended up being great. Like people still talk about how the iPhone came out and it changed the world. But at the time it came out, or shortly after, like 2-3 years, everyone was trying to make everything mobile. And eventually they realized not everything needs to be mobile. Not every website, not every app, not everything you do needs to be mobile. And so it wasn't quite as severe. I think the iPhone was extremely successful on Android phones. But you did get this sort of thing happening. And now we're in this plateau of productivity that we know where mobile phones excel. And there's been huge solutions and advancement, like Uber, right? That didn't exist before the smartphone, the iPhone, Android phones. So, I think we're there. I think we're about there. We're just coming over that peak. I think it's starting to set in with people that, oh yeah, this is not quite what I thought it was, but it's cool. And we're sliding down that. Like when I talk to people, they used to use ChatGPT all the time. And now it's starting to be, yeah, I guess I haven't used it in a little while. There's still some people I talk to that use it for everything, but we're kind of sliding down that peak. And what I believe is that we will figure out what it's good at, and we'll get to that plateau of productivity. And so just to conclude some of my thoughts and kind of try to put it all together, generative AI is a really amazing technology. It's super cool. So I don't want the takeaway to be like I'm anti-LLMs and ChatGPT. I'm not at all. I just think we have to live in reality a bit on what these systems are likely to do. And what I believe is that the software engineering practice, there's a lot more than writing code. If it was just writing code, if it was just, hey, write me 3 lines of code that does this and come back to me, and okay, great. It's not. There's so much more to it. And I was trying to illustrate that point earlier. The writing of code is a small aspect. It's an important aspect, and you want to be very good at it. But before you even write code, you have to figure out what solution you're solving. What does that solution look like? How do we, even that to-do list app, right? Like I had to say, I want it to work this way. I want people to rearrange items, and I want it to save. So when they come back later, they're not frustrated and have to create their to-do list again. That's a super simple one. As you get more complex problems, that figuring out the way that it needs to work and how it needs to join with what's possible technology becomes a more and more sophisticated problem. And that isn't answered by these LLMs and other AI solutions, at least not yet. I think what is likely to happen and where we would finish out on that slope and get to that plateau of productivity is that we find a really great way for these AI systems to partner with software engineers and really accelerate their work so that they can focus on where they're adding the most value. But the reality is, even with this AI tooling, the creations are going to get really complex, and it's going to need someone to understand the designs, understand the way the foundation works, the computer science stuff, and be able to help that AI craft the right code. And that's what software engineering really is now, is that, and it's going to become even more important in the future that people are working that way, and this just becomes a tool. So, that's actually it. That's the end of my presentation. Any questions for me? Yes, go ahead.
So, I think no one disputes the fact that the current LLMs are pretty terrible. So they are pretty terrible.
I think they're great.
I mean, based on like our design standards
Yes.
for software engineering.
Yes.
But I think the people that are optimistic about these LLMs are optimistic based on on the predicted developments, right? So they're
Yeah.
predicting that it's going to improve much more. So so the current ChatGPT is at an infant stage.
Yes.
It's going to improve much more. So that's where they're coming from. So
Yeah.
my question to you is that, do you think that this LLM-based approach is the way to improve the generative AI landscape? Because I see a dead end here. So
Yeah.
you said that the temperature is like 0.8, right?
Yeah.
So it's just random. So I do not see how we can improve it significantly. So
Yeah. So my understanding is the way that they're improving is they're making changes at the model layer, but there's actually a lot of work that they're doing between where you prompt and what it actually gives to the model. There's a lot that they're adding in between, behind the scenes, to help increase the success. So I think there's going to be more progress, and I think it will improve. But I have the same sense you do, that it's a bit of a dead end, and I think that's where that graph, I think that's where we'll continue to slide down, as there was this feeling. This thing came out, it's progressing so fast, right? Like the image generation is a little bit of a different beast, but like you could visually see there's an image that looked, kind of weird, but it was cool that a computer made it, to photorealistic. It's almost hard to tell that it's not a photo. So seeing that progression is super impressive, but I do think with the current approach of this basically predicting the next word, you're fundamentally in the problem of the hallucinations, right? It's not grounded in what it doesn't know. It doesn't know anything. It has no idea. It's just predicting a next word, and I think that is a hard limit. There's smart people work on it. Maybe they'll find a way around it, but it just seems inherently with the design that they're going to have to figure out how to embrace that, and then get to that plateau of productivity, because we find the right problems that are fit for it. Yeah, go ahead.
So LLMs are generating text based on the training dataset. So the generated text are like the sophisticated mimicry of the training dataset. So if we use LLMs in our daily basis, will it create a long-term consequences?
Yeah. So let me repeat, make sure I understood it. You're basically saying if LLMs are trained on data that's out there,
Yeah.
text data that's out there,
Yeah.
to say, here's the next likely
Yeah.
word, well, now people are starting to generate text using these tools, and is that now becoming part of the training set?
Yes.
I think the answer is yes. I don't know what chaos that's going to create, but it feels like it's going to create some chaos. It feels like that's going to be a problem. Yeah. Let's see. Any other questions? Yeah. Go ahead.
Students are using LLMs quite often. They are
Yeah.
doing assignments, homeworks, and whatnot.
Yeah.
So, do you think that it will affect students' creativity and all creativity things?
Yeah. Well, that's an interesting thing, because if you think about, well, what is the future of software engineering, I think it's definitely part of the future of software engineering. So, is it wrong to use it? I think that it's like calculators, right? Like in math class, there's many areas where you weren't supposed to use a calculator, right? And kind of learning the basics. And that's because if you just went to a calculator, you would never learn the basics. And so I think we just have to take a similar approach. But once you get to advanced math, have fun. Do what I offload as much as you can with the calculator, because you still have to understand how to hook together the concepts. And if you don't understand that, the calculator isn't going to help. And that's kind of what I see with this too. People will be able to create, people that have no background in computer science, programming, they're going to be able to create cool stuff, but it's going to be pretty limited, right? And so what usually happens with technology is the bar rises. The easier it gets to create things, then you all are going to be spending time on more complicated problems. So it's actually going to push everything higher, and it's going to push us all forward. But the problems we don't just set the bar there and stay there. So that's actually why you won't be out of jobs. You'll be working on the next level of what we need to do with software engineering. Any other questions? Yeah.
Sure, a lot of people are scared of heavy AI, which is mostly the software engineers. So what is your thought about heavy AI?
What was that one?
Heavy AI, sir, a software with AI model.
Oh, okay. I think I've heard of this. So it's more like it will do the whole software engine. It'll try to do it end to end. And so I was trying to remember what that is because I remembered about that, and I think that's the one. Okay, check my facts here, right? I might be hallucinating, but I think that one is kind of interesting. They have a lot of investment. There's a lot of people getting excited. But if you go to their website, again, check this, make sure I'm right. You can tell that the website, if you inspect the code, it's not created using Devin AI. You can see it's created using a human. So I don't have an opinion about it. I haven't used it. I don't know enough about it. But I think my general concept here, I'm guessing they're not going to be successful, or they're going to have to figure out a very confined area that they can work in, because I just don't see how the technology is there to really do software engineering through purely AI.
Thank you, sir.
Yeah. Any other questions? All right. I think we're done. Well, thank you so much, everyone. It was great talking with you all, and thank you for the great questions. Really appreciated it. I should plug Field Nation. I talked about Field Nation. We're hiring software engineers. So if you're interested in learning more, please reach out to us. We'd love to contact you all. All right. Thanks, everyone.